Hi, Bill. Hi, Bill.
Hello, how is everybody?
Hey, I'm fine. I still hear an echo though. Yeah.
I couldn't find my earplugs.
Oh no. Oh no.
All right, I'm going to mute for a little bit.
Okay. Okay.
Let's see if that fixed it. No, I don't know.
Yeah, I turned your volume down a little bit too, Bill. So that seemed to be helping a little bit.
Yeah. 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 Well,
I'm going to escape to find my earplugs.
Well, I'm still hearing an echo. So you had Bill muted. I got an earplug, and I don't think it's me. I'll try.
okay. Yeah. Do we still hear the echo?
Sounds like it. I'm gonna this muted. Let's see.
I'll unmuted myself now.
And I don't hear the echo anymore.
How about now?
How about now?
I'm okay. It sounds okay to me.
Okay, I don't hear an echo either.
All
right. So I guess we're live.
Yes, we are.
There's a lot of interesting stuff going on.
Yeah, there are quite a few interesting projects. The big thing I've been noticing is that new people joining us has gotten a lot more accelerated, and that's kind of interesting.
Yeah.
Lydia has to run in circles like a hamster in a non-functioning wheel.
Pretty much.
Let's see.
Well, we could always use more people who want to do welcoming committee type things.
Yeah, we might see if we can find some of the new people and see if we can find some of them that are good at that.
Ah.
But I don't know which of the new crowd to suggest.
That's okay. Well, actually, welcoming committee isn't all that difficult. We have various blurbs for various reasons, and we can do those if people would like to do that. But I'm not putting anybody on the spot. I'm just saying what's available.
I see Les Hall's interested in joining Trouble.
I just posted the invite. Yeah, I am. The main reason it seems like I'm not paying attention to what you guys are saying is because I'm paying attention to all the other windows to make sure that nothing comes in and I miss it.
Yeah, I'll help monitor the event post and the Q&A.
Okay.
Let's see, events.
Hi, Arden.
Hey.
I'm going to turn your volume down just a little bit. Actually, that's not bad. And I'm going to turn your volume down just a little bit too, Russ. For some reason, there's a lot more echo than usual tonight. So, I don't know. The one topic that I did mention in the Hangouts about the new Whipple tree box, the grip adjustment device.
Right. I wish I had one with me to show and tell. Several people have asked to see one. I hope Jason joins us. He's got an interesting looking one. I'd love to see it myself.
I invited both him and is the other guy's name Theory or Fiery? I don't want to mispronounce it, so I'll probably ask him how it's pronounced the next time I talk to him.
Is that the guy from France?
I think so.
Yeah.
The other one has been proposing variants of Skip's Whipple tree.
Yeah, Jason Bryant is in China. So about his timing on this. I don't know what time it is there right now, and I don't know what time it is in France either. So they
that's right. Jason's out in China, isn't he? So it's
Yeah. So they may both
40
be.
hours there. Yeah.
Yeah.
Or it may be just breakfast time. I don't know.
I think it's 1 a.m. in France.
Jason's in China, I think, Les.
And Pierre, I guess.
China, they're usually, well, they're pretty big, though. There's several time zones.
Right.
But they're about 12 hours away, aren't they?
Yeah, so it's like breakfast time there, and it's supper time here.
Yeah. Britain is about 9 hours ahead of us. Well, ahead of me over in the Pacific.
Oh. 8, I believe, yes. Yes, about 9. Because there's 6 from me, and I'm central. Except when it's British Daylight Savings Time. Somebody let me know if this printer is gonna make too much noise.
It's all right. I just needed to turn your volume down a little bit to
Okay.
reduce the amount of it disturbing the other. We've got a feedback loop somewhere that doesn't happen too often, but some of the background noise triggers it. So we've had a few moments of having to bounce IT up.
Okay.
Oh, hey, Jason's here.
Oh, hey, Jason.
I mean, not in the call, but apparently he's in the Q&A section. Jason, do you want to be part of the call? Let us know in the Q&A.
I hear that feedback, yeah.
Yeah. Yeah, so if you hear that, can you mute while it's doing that?
Was that from me?
I don't know. I just keep hearing something that sounds like a cruise ship horn.
I think it is Les's printer.
Is it? Maybe. Let me mute and we'll see. Whoops, no, that's the hangout button.
Okay.
Oh, but actually, I really only had one major thing.
Okay.
Lydia, I tried to text you once or twice. No, I don't think that's my printer.
Okay.
Can we meet to go over spreadsheets and how do I represent this document? It's an ideas document as a spreadsheet.
Yeah. Let's meet sometime this week and we'll do that.
Okay, sometime this week.
Yeah, just ping me through the IM system and we can figure out when.
Okay.
Yeah, and Jason Bryant says yes, he's ready to join.
All right, I'll send him another invite.
And yes, Jason has some show and tell.
Great.
I want to see
Yeah.
that.
I think can't everybody see the Q&A section if they click on it?
I think so.
Yeah, so click on the Q&A section, you can see what Brian sees.
Oh, Q&A. Okay. Can you watch Q&A and the chat at the same time?
Well, when the Q&A is clicked, you will see a little red number 1 or 2 or whatever on the sidebar chat. So you'll know. For some reason, when you're in the sidebar chat, it doesn't show up that there's any Q&A, but when you're in the Q&A, it shows up that there's a chat message.
Because the chat app was better written than the Q&A app.
Pretty much.
Whatever.
Oh.
Hey, Jason.
Hey, Jason. I'm going to mute.
Hello, everyone.
There's something noisy in your background. I'm pretty sure it's yours because it goes away when I turn yours off. If you need to talk, feel free to unmute. but I'm going to try to keep you muted when you're not. All right, sorry. Go ahead, Jason.
Sorry, Artie.
Hi, everybody. I've got this hand I made, and it has my little box on it. I'll call it the grip balance box, maybe gripper box, anything that is a little more descriptive than just Whipple tree. But the basic idea is that when you close it, the fingers can individually adjust. So if I pull on these two fingers, there's still some tension on the other fingers. This is as opposed to the classic hand, which has a regular tensioner box on it. You can't really do that. If I pull on these two, there's nothing on here. And I can demonstrate even better by having it try to hold an object. You can see there's nothing on this finger, nothing on this finger, really nothing on this finger. It's just the index finger has all the pressure. If I do that with the grip balance box, all of the fingers contribute. I can even pull the top one off, maybe even the second one. The bottom two fingers adjust. So you get a much better grip.
I love it.
It deserves applause.
Yeah. Still got a few ideas on how I might make it a little smaller so that, well, the ultimate goal is you'd hope to be able to get a coat over any hand we make, so I want to get it as small as I can, but I'll just keep that as a work in progress.
I think you've done a beautiful job. It's a lot smaller than what I was playing with, so I'm just totally pleased. And that's like a 100% smallest size hand, is it not? So
yes,
when you make the hand larger, you don't necessarily have to make the Whipple tree larger.
No, scaling it's a little tricky though because it goes into the balancer box's base. See, the actual tensioner pin cuts into the base, so you can't just cut it off and scale down the box and leave the shoe. So that's
That's a challenge. Let's think about that. Might be able to do something about it.
Yeah. So some parametric designs might help with that, but I can't do that. I don't have Fusion 360. I can't get it here because I can't download it properly. But it's got some potential with that. The one I'm going to do for a recipient, he needs a hand that's about 180. And you can see I've got the regular Whipple tree here, and it doesn't leave enough room. That's what got me thinking I needed to move it down and put it inside the box.
Great.
So when manually I took the regular tensioner box and put it at about 140 while leaving the base the same so it could slide into the gauntlet. I'll do the same thing with mine manually. That's not a great solution for everyone because somebody might need 141% or some other size, but I'll try and work on what ranges I think it can be shrunk down to. Move it down and put it inside the box. So it went manually. I took the regular tensioner box and put it at about 140 while leaving the base.
Did we lose it?
Where'd he go? Which way did he go?
What?
Yeah.
He disappeared.
Oh.
Invite him.
Well, you can rejoin. You just click on the same link.
Yeah, I know.
Oh, okay.
But an invite gets you in faster usually. The invite notifies you directly usually. Don't actually know if that's true. I've not played on the receiving end of video hangouts much.
Huh.
Yeah, I was going to ask him to show the other Whipple tree. Hey, Skip, do you have an example of one of your standard Whipple tree with the
Not built into a hand.
have one that's handy so we can basically explain the mechanism? for what was the little lady that was asking questions about how it works.
Yeah. Basically, it has the same triangle shape as the original Whipple tree that Steve Wood showed us, but it's like a sandwich.
Right.
And what I am doing and
Basically
what
two
Jason is doing is running the strings around a pulley, except a real pulley. I'm not using a real pulley. I'm just using a peg, and that seems to work just fine for me. I'm using a piece of 3mm filament as a peg, and just making a rivet out of it with a hot iron. And so the smooth surface of the 3mm filament works just fine. Now, what you do is you get the strings from fingers 1 and 2 to loop around one peg. So it goes from finger 1 around the pulley back to finger 2. And those two things, when you pull one down, it pulls the other one up, and so forth. You know, they balance each other off on the pulley. And you've got the second pair of fingers that are on the other pulley. And then one pair balances the second pair by the whole Whipple tree pivoting on the post. And so you can see how that accommodates. Now, here's what hasn't really been mentioned that I think is so great about it. When you're using the pulley, better than the original one where you've got 3 little triangles held together by strings, when you're using the pulley, it is self-balancing, and you don't have to worry about how long your individual strings are. If you get them anywhere close, it will just adjust itself. And that's great to me. You got fewer knots to tie. You don't have to be so concerned about getting it all balanced. Are you finding that to be the case with your pulleys, Jason?
Actually, I like to get them pretty close because when I look inside the box, if I extend fingers a lot, it actually turns the tree a lot. So from one finger to the next, they do need to be pretty tight, but the problem is pulling these 2 fingers versus these 2 fingers. That still depends on a tree. So when you wire it up, you need to kind of hold 2 fingers on the box to make sure that the tree stays level.
Right,
and
that makes sense.
I tried to make a little jig that I could insert here that would keep the tree moving back and forth, but that didn't work out so well. Maybe I can try that again with a little more space.
Well,
but
I think you can get that to come out pretty close though, just tying that one last knot.
Yeah, that last knot's the tricky one. You end up having to hold
fingertip, and that's the only one that's tricky.
Yeah, you have to hold 2 fingers here to keep the Whipple tree from moving, and then a couple more fingers here to keep this at about the 30-degree angle that you want. And I got a little bit of practice at it because I did it a few times, so it's not too bad, but it's a little bit of a trick. But wiring a little bit of effort on that last wire just to make sure that it all stays balanced. But then it's 4 knots to tie instead of 4 knots here and 4 knots here, so it's still less knots.
Now, let me ask you, Jason, to use your balancer and do a little experiment. If you can you pull back on your tensioner so it slides back in the dovetail?
Yeah, I can take the dovetail out and slide it back a lot, but I've only got a little bit of leeway here because I have 2 screws.
See what's happening though. When you do that, if you pull your tensioner back in the dovetail, when you straighten your wrist out, you've made a fist with your wrist straight rather than with your wrist flexed. So if you grab a handlebar, you can hold a handlebar with your wrist in a comfortable position if you pull the tensioner back in the dovetail. So I have been playing with making that easily adjustable on the fly. Here's one of the flat, printed flat gauntlets, and I modified the dovetail so that it's got a little washboard kind of feature in it, and I made a little toggle on the slide with a little tooth that sticks out and fits in the washboard. So when you want to slide it back, you just tilt it and it pulls the tooth out of the washboard. If you want to slide it forward, you tilt it and it pulls the tooth out of the washboard. And I haven't got it all put together with the hand yet, but it looks like it's going to work. And so I can lock this thing with the fingers gripped, with the wrist not flexed so much. And that seems like it could be a useful thing to me. And so at any rate, I'm playing around with it. I don't know if you can follow how it works.
Like changing gears in a car, but instead changing gears in your hand?
Yeah.
Actually, that's really cool.
I have a question. Are all these great ideas that we have individuals working on them. Is there any kind of, I know there's been some talk about it, but has anything sort of congealed in terms of a way of tracking, their progression and moving them into the Hand-O-Matic where people can, get STL files for them?
I think the forum will help a lot with that.
Yeah.
I mean, the Hand-O-Matic really is for final enable hands, the enabled devices. And that goes through, they have to be tested on recipients, and, we have to know what goes on there. The R&D stuff, I don't really think a lot of the projects would ever end up on Hand-O-Matic.
I think the forum will be useful because any of these new projects can stay on the same page. There's probably it'll probably be easier to find specific projects, and sub-threads off of the projects will probably be easier to keep track of.
Mm-hmm.
Yeah, this will be a good topic to try that out with. And I certainly agree with you, Les. It'll be a great improvement if we've got a way to, for instance, find how many people have tried the STL files that Jason published, and how many have tried the STL files that I published, and how many people have tried the modification of either one, and which ones have what kind of problems and so forth. We don't really have a way to do that right now. And if the forums will solve that problem, that'll be great.
Yeah, that sounds like a terrific solution. That's good. I had started putting together an idea doc. That's what I had mentioned to Lydia, but I don't think it's necessary anymore with the forums. Should we?
Yeah, well,
put
let's see how it works out. And if you see an application for it, plug it in, and we'll see how it works.
Okay.
Well, I know one thing I was really interested to get into, I saw you mention it briefly, Trouble, was elbow ideas, for either actuated elbow or an articulating elbow. We're seeing more and more requests of people that have, maybe 4 or 5 inches below the shoulder where they have plenty of movement like that, but nothing above the elbow.
Yeah, the RIT arm was designed with below the elbow in mind.
Yes.
We've thought a lot about ways to make shoulder shrugs cause the hands to flex. Um, I'm not sure what the status on those projects are at the moment, though. But yeah, there is a lot of thought on what to do with more severe amputations.
Yeah, I think my opinion with, and I've got very little anecdotal data and experience with the different kinds of arms personally, but I have seen the harness in use, and so the shoulder actuated, shrug the shoulder to move the, fingers. And I've seen the elbow actuated, and I've seen an arm that could be designed to work with either the harness or the elbow actuation. And there's some pros and cons. Basically, if you want to do some work, if you actually want to play tennis or do anything where your arm might fall off, you're going to want the harness, but the kids that just are glad to put their cyborg hand on and be Iron Man for a moment and take it off when it's convenient to have it off, on and off real easily. The harness can be a burden, and so I think there's probably going to be recipients that would like one and others that would like the other, and I don't know how to advise them yet. But as we get more feedback from users out there, we'll probably be able to learn to make that recommendation to the fabricator. Kind of questions to ask the recipient.
Yeah, 'cause, well, I have a recipient right now that needs one. It's one of those almost fell into my arms, no pun intended, but I've been working out of a makerspace and doing classes and teaching. I have my printers there as full-time e-NABLE machines. I saw 2 of my printers. And the owner of the makerspace came to me and he said, the janitor of this building only has 1 arm. And I'm like, well, not anymore. So, so I've been working with him, and there's some language difficulties, but he has a shoulder and about 5 inches, and I've been trying to come up with ideas. And he says, what he needs is, he's a janitor at the building, and he says sometimes when he's, putting up the 8-foot fluorescent lights, it'd be nice to have his other arm so he could hold it up there, just some kind of a locking elbow. And I had the privilege a couple weeks ago to go down to Dallas with Ivan Owen and Jen, and I ran, and I got to run a couple ideas through Ivan, and he had mentioned, like a locking ball joint, or the very top of like camera tripods, how they'll have a button and you can hinge it and then you let the button go and it locks.
Right.
Yeah.
Something like that, where he'd be able to hinge it into a position and then lock it, and maybe it would be straight out and he'd be able to hold something up. Or I've been playing with ideas like that, but man, it's not easy.
That brings up. Oh, go ahead, Skip.
No, I was just saying that's a worthy project. So thanks for throwing it out there, and maybe some other people have some ideas also.
It does spark something in my mind, which is something we've seen, or in my short time here, I've seen bits and pieces of where, such as the Aaron Brown's Python stuff, where we're not even attempting to make something that even looks like a hand. Or like the guy who wants to make the welding attachment so someone can, I think he said TIG weld. It seems like there's a lot of opportunity to make assistive devices that are not prosthetics at all. Utility. That's our word for it, utility?
Well, that's what I call it.
Yeah.
Yeah.
And the prosthetists call these terminal devices.
Right.
And so you don't necessarily, you know, a hand is one kind of terminal device. A pair of hooks that are held together by a rubber band is another common terminal device for arms. And, you know, the Swiss Army hand, like
Yeah.
Aaron's Python, is a very versatile terminal device. And so I think that's got so many possibilities. But Aaron, you know, you could possibly put a Picatinny rail up close to your janitor friend's shoulder, so he would have some good leverage on a special tool that could help him, you know, for putting in a light, for instance. I don't know if he would need a dynamic active hand, if it was just to help him hold something, you know, if he had a sort of a thumb in opposition to a palm-like function on the as a terminal device on the end of something he could put on his Picatinny rail, you know, he could just hold it up there. I don't know. Just throwing out an idea that popped into my mind.
Sensor design. It's two fingers that go together that squeeze together.
Yeah. So it could be active, but more simple than having 5 fingers.
Yeah.
You know, one of the things that the pincer type hand brings out that is interesting to me is that with one of those, it would be really easy to make a wrist that can rotate 360 so that you could turn it to whatever angle you need it to be in. So if you're putting a long light up in the thing, you could rotate it so that it's pointing the direction you want the light to go. And if
yes.
And it could be the same thing where the rotation is locked. Once it's in place, it stops.
Right. So your rotating feature could be way up against the shoulder on a harness rigged arm with above elbow attachment.
Or the elbow, by the elbow maybe.
Yeah.
Like they have locking ball joints, or locking, well yeah, it's a ball joint, where it has a little, you know, you turn the knob and it loosens it, and then you can swivel the ball and turn the knob and lock it again.
Right.
You know, and if that were at the elbow, you know, you could lock it straight, or you could lock it to the side.
Yes.
Try to get the
like the
articulation.
RIT arm has a, you can lock the wrist in any orientation, and you basically leave it where it's useful to you until you find it needs to be a different orientation for a different use. And your elbow could be that way too. So I think that's a great idea.
When I asked the recipient, you know, what he really wants, that's all he, and again, there was a language challenge, but he kept focusing on the elbow and being able to bend it and lock it and hold it. So that's feedback from, you know, that's direct feedback from the source. So that's something I've been focusing on. If that's what he wants, that's what I'm going to try to do.
Yeah. Now, Albert Chee's team at Johns Hopkins made a design for a ball joint, and we tried printing some of them, and the ones that we printed were not strong enough. They broke very easily. So we're still looking for a good ball joint printing design for arms, in my opinion.
I've got one for you. Sorry for the background noise. It's my roommate. The camera mounts, ball mounts for cameras.
Yes.
That might be a good place to look for parts to put together, something like that. But
Yeah,
that's a great idea.
optimized.
And that's what I got from Ivan, and that's what, you know, not printing that part, but, you know, printing the cup and the adapter to, where you just modify, you put the screw holes in there so it can actually screw, and you put that ball joint like an aftermarket part.
Yeah, right. And you know, it's coming back to me that I actually look for those like on Amazon, and you can get parts like that fairly inexpensively.
There's a lot. One thing I really started looking at too is if you Google articulating monitor arm, just
Yeah.
the arms that hold up monitors.
Wow.
If you start looking at those, like, man, those look like really expensive prosthetic arms, and they're articulated and they can hold, 30, 40 pounds.
Wow, what a great idea. If you see
Like,
something you like,
yeah,
post it, Aaron.
like reverse engineering something like that,
There you go.
using that as almost a skeletal system and printing outside of yeah.
Plus, if he wants to watch TV, there you go.
You guys have seen the flexible camera tripods?
Yeah, the kind of octopus arms.
Yeah. It is an interesting idea to me to mount one of those with the tripod pointing away to use as fingers, so you could wrap them around whatever you wanted to carry. And I'm not sure it's a great idea, but
yeah. Well, I haven't had any personal experience with those. I never went out and bought one. Have you seen anybody use one? Do they work well? They seem to me like they might be kind of unreliable in terms of whether they hold their position or not.
They work pretty well. I used to do a lot of urban exploration, which is exploring abandoned buildings, and one of the guys in our photography crew used those a lot, and they put up with some pretty rough abuse.
Okay.
We had to wash them off a lot too, because there's some nasty things that you don't want to bring home with you.
Oh, that's another consideration too, is making our hands and arms easy to keep clean.
Yeah.
Not to be concerned about getting them wet, and easy to clean up and so forth.
You're making me think of, I guess we're turning into a little more of an idea session here. You're making me think of, I'm not really a mechanical engineer, more electrical, but this 3D printing is sort of bringing out the mechanical engineer in me, and I really could see if I was actually just being a handed person, so many times I need a third hand.
Yeah.
Right.
I would love to have something that attaches to me somehow and gave me an octopus arm. I want to be Dr. Octopus.
Right.
But really, I think maybe it makes sense not to try to imitate the human form so much,
Right.
and to make more task-oriented type of devices, such as for this janitor.
I just put a link. I mean, it's just images of, articulating monitor arms. But if you start looking through those and thinking about, like, boy, if we could take one of those nice ones apart and, reverse engineer and modify it to, put bike cables along this, using 3D printing to, almost use some of those as like the skeletal system for the arm. It's like a framework that's already there. And if you look down that page that I just posted, there's hundreds of different designs. Granted, some of them are pretty expensive, but I keep seeing, every once in a while I'll see one and like, wow, that might make a neat looking arm, or an elbow.
Yeah, I think that's a great idea. And, that's another advantage of the Whipple tree or otherwise adaptive gripping device is you can have one single cable or wire running back to your shoulder harness, rather than the traditional way to set up an RIT arm is you've got 5 tendon cables running all the way back to the elbow joint. you know. And if you put a Whipple tree up here, you can attach the thumb to the base of the Whipple tree, and so you've only got one wire running back. And you can put a Bowden cable, you know, just a sleeve on that, and hook it to your harness up wherever you want it, and the whole arm could articulate to whatever you want. That seems ideal for your janitor, doesn't it?
Mm-hmm. Yeah, and just modifying a way to make that elbow lock.
Right.
Using
But
something.
certainly the monitor things do that. I mean, the monitors stay where you put them, and that's great.
Mm-hmm. Yeah, it's going to be a fun project. At least I'm at a makerspace, so I have a lot of people that they like
I
taking
love
things apart.
makerspaces.
This is the section of the conversation that it would be nice if Bob Roth were here.
Mm-hmm.
Yes, yes, he's got something neat going with Jeff.
I sent him an invite. I didn't send it earlier. I didn't see him on the list of wanting him. I didn't want to.
It occurs to me also maybe the use of muscle wires. I'm sure you're all familiar, but I'll mention it's a metal that when you apply current through it, it heats it up and it contracts about 10%. And I could see some kind of tentacle-like thing that you activate the muscle wires in order to change its position and orientation.
I've managed to make a couple of pieces of it work, but I haven't had the time to play with it that I've wanted. But have you seen the nylon monofilament fishing line muscle wires that have been made?
No, tell us about it, Trouble.
It's just you need to put a weight on it, and you need to tie it to or grip it in a drill, and slowly spin it until it starts to double up and pull itself tight. And then once that's done, you let it hang for a while, and then it contracts when you heat it, and it expands when you let the heat off. So
interesting.
Wow.
It's one of the strongest. It's one of the strongest monofilament, or one of the strongest muscle wires that has hit anything. But it's
that sounds great. I'd love to see you play with it.
Hi, Bob. Hey, how you doing?
Great. Good to see you.
I gotta find my glasses. Oh, there they are. I can't think without my glasses on.
I think you brought a nectar with you, Bob.
Pardon me?
Yeah. Bob, can you earpiece something?
I gotta say again.
Earpiece?
Yeah, I'm good to go now.
I know, but
we're
echo.
Oh, you are? Okay.
Change your volume.
Go ahead and mute me for now.
Okay.
This is kind of what the muscle wire looks like once it's been coiled up correctly. You basically just spin it until it coils up on itself, and then adding a heat source causes it to contract, and it loses the contraction when the heat goes away.
How much contraction does it get? Do you have an idea?
I would have when I first started playing with it, but it's been a while. Hold on, let me see if I can dig up any.
Was it 1% or 10% or 50%?
I think it was around 50%. It was
wow.
a big, large contraction.
Well,
I haven't
one thing to concern that'll have to be dealt with is that if you use electricity to generate heat and then you use the heat to generate a mechanical motion, you got poor efficiency in the whole system,
right.
Typically. And so there are bimetal strips. You put two different kind of metals welded together, and so one of them responds to heating with more extension than the other, and so it bends back and forth. Thermometers work that way. And one place to use those is in the blinker on an automobile turn signal. Has a heater and a bimetal that makes it go back and forth.
Mute you for a second, Bob.
And so, you know, there's a possibility of actually making a bistable device where you don't need to apply the heat continuously to hold it in a position. You can momentarily apply the heat and make it flip this way, and then momentarily apply heat to a different one and make it flip back that way. And, you know, logic can make that work out for you. And that would become very efficient if you didn't have to apply heat continuously to hold the fingers in a flex position.
Yeah, I don't know what the lifespan of the nylon wire or the nylon fishing line will be when it's under heat for long durations. So that's one of the things that I was going to do some more testing with, but haven't really gotten to do much of anything with it. I've made a piece that contracts and can lift, you know, a few grams, but I don't have a low enough control heat gun or precise enough controlled heat gun. The ones I have a tendency to melt the nylon completely.
Yeah, that's something to work out.
Yeah. So, and I don't have a hair dryer anywhere. So otherwise I would use one of those. It doesn't need a lot of heat to contract. It just a little bit.
Yeah, so you might consider using a power resistor and wrap your string around it and use a controlled current through the resistor as a little heater, kind of like the heater in the nozzle of a printer.
Okay.
Did you mention nichrome wire? I tuned out for a second there.
Yeah,
Is that what you were using?
So
if you wrap the nichrome wire around the monofilament, then it would flex with it.
Yeah.
See what I mean?
That's an interesting idea.
And you could run very little. I wonder also about the use of Peltier devices to provide the cooling, because you know once you heat them up, you'll get quick operation. You want to cool them.
Could you say that again, Les? What kind of device?
Peltier devices. Are you familiar? You must be, I'm sure. Peltier. It's a French name. They're basically they're diodes, and you apply, say they're usually like 12 volts in one direction, and the one side gets hot and the other side gets cold.
Oh, okay.
You've heard of those, yeah. And if you apply the heat in the other direction, the one side gets cold and the other side gets hot.
Okay.
They used to be really expensive, so they were originally used for the needed in satellites and things like that. But now you can buy a pack of however many you want for pretty cheap on Amazon or eBay or someplace.
That's interesting. That'd be worth fooling around with.
I've played with them just a little, you know, just enough to feel the hot and the cold, and it can be a lot of heat difference. So if only a little bit of heat difference is needed, we might be able to get rapid cycling of the flexing motion from long thin Peltier device. Maybe set some metal bone core with a Peltier device contacting it, and then the flexible monofilament terms contacting that metal.
Yeah.
don't know, something along those lines.
That sounds like a fun project to get going at a makerspace or a student project or something to get somebody to play around with it.
Yeah, the thing that I wish Laird was here, but he said to me that I didn't realize this, that there's there's a lot of grad students who are just chomping at the bit to get good ideas like what we're coming up with here, because they've got the education, they've got the background, they've got the ability, they've got the time, you know, but they may not necessarily have a good idea to focus on.
Right.
I mean, I presume that's true. What's the fact about that? And, you know, he was suggesting that we record these ideas so that we can present them to grad students, and maybe there will be someone who will carry them out.
Even undergraduates and high school students, that's a good idea. So if in the forum we can have a place to kind of put a wish list for projects that are just kind of the skeleton of an idea for something to explore. I think getting students involved, am happy to encourage students at RIT to try their own projects and to give them encouragements and so forth. Even for no credit, but just for the fun of exploring and giving somebody an idea that could lead to something useful for e-NABLE. e-NABLE's obviously a useful activity, making the hands and arms and things that are exploratory with technologies that'd be useful to us would be great student projects, in my opinion. So science fair projects for high school kids, undergraduates, as well as graduate students.
I mean, that's what's happening in Alabama right now. So our school actually got jealous because everyone else was making hands. So we got put on a project for that for our senior design project this year.
Oh, terrific.
That's great.
So actually making hands for recipients, pardon?
Well, right now we're actually taking a raptor hand and we're running FEA analysis on it to try and figure out like if we can improve it at all. And then we're running EMGs and a servo motor to try and just have it where if somebody didn't have a wrist, where they could just flex their bicep or something like that and go from there. And then I think there might be a group after us that might improve on that idea a little bit more.
Is this at the high school level or college level or?
Undergrad at Alabama.
Undergrad Alabama, okay.
Yes, sir.
That's terrific.
Yeah, that is really good. I remember.
Be sure you let us know what you find.
Oh, absolutely. I'll post it on there.
Yeah, of course, the first makers were working on projects like the wheel and ways to start fires and things of that nature. But you know, we've been makers all along. But in my particular maker days were in my undergraduate days at NC State, where I did do projects. It took me a long time to graduate, partly because I would always do a project. And you know how that takes up all your time.
Oh, don't lie. The reason that took you so long was because you're having too much fun. Come on.
Yeah, that's true. Yeah, I was having a lot of fun. I did work. I did co-oping, which adds more time and stuff like that. You know, worked in the research microwave lab. I had another little show and tell. It's not much.
Okay.
But I can't really test it, and I'm hoping to get some ideas. Let me hold it up real close to the cam here. This is what I had posted some time ago on the forum. Sorry for the chewed off fingernails. It's better than dirty fingernails, I guess. But it's a little finger ring. In this case, a size 9 that fits my index finger here, and a arm. Let me take it off my finger. an arm that holds 2 magnets, and this I didn't. It's amazing what you think of and what you don't think of. I kept coming up with ways to use the plastic to hold the magnet there, and when I actually got the magnets, someone sent them to me from e-NABLE. It suddenly occurred to me, duh, they stick to each other.
Oh yeah.
So all you have to do is keep them from sliding off, which I didn't really do yet. But
You could do that with the shape of your printed plastic part. So yes.
yeah, yeah, keep them there, keep them from sliding off with the shape of the plastic part, and just let them grip each other.
You could
so
actually.
the idea. What?
Oh, I
So
was going to say.
tell us how you use it, Les.
Oh, well, the concept is, if you haven't heard, some people have begun to have these neodymium supermagnets and related supermagnets sewn into their fingertips, so that they can sense magnetic fields and therefore sense electricity running through household wiring, through a stove or something like that. And it works. People are doing it. But
That is surprising. Can you feel it with your device on your finger? Can you put it up next to a wire and feel it?
I don't have enough current flowing anywhere here in this nursing home room to test it, really. And I wondered if I could mail this or print a few more of them of different styles. And I've got a few more magnets. If I could mail these to someone or just pass the idea on, it's nothing to CAD up a little thing like this and put a couple magnets on it.
If you could just take the wire that's running to an appliance, like any appliance in your kitchen or your office or your bedroom, and you hold your finger up next to it and you could tell if it was on or not, that would be something. If it's not powerful enough for you to sense things like that, then it would not be nearly as useful as what I thought you were describing.
I bet you I could use the bed. I have an electric motorized bed, and it's got pretty big motors because it's capable of, I'm a very big guy, and it'll push me up and down.
Right.
So, that thing must be pulling some current.
Well, presumably anything that you plug into the 120 volts AC 60 cycle power, if you could hold it next to any power line and tell if it's on or not, that would be useful.
Yeah, well, your 3D printer.
Yeah.
Well,
who said that a minute ago?
It's a lot of power.
Ah.
Printer, it's.
You'll have to get on the AC side of it, okay?
Yes, I've got the wire right here to the printer, and I don't sense anything. But then again, it doesn't draw like an appliance.
How about getting on the other side of your power brick? You got to get on the AC side of your power supply.
Yeah, I am. I have the wire here, but it's again. There's like the biggest power draw on a 3D printer is the heated bed, which is about 150 watts, and it doesn't have one. It's about 40 watts for the hot end.
The stepper motor, the most rapidly vibrating electromagnetic field.
Wow, that's.
What?
I said your stepper motors should use the highest frequency vibrating electromagnetic field.
Well, the magnet just jumped off the end of it onto the stepper motor. But, let me hold it up. Let me redo it and hold it up.
I think you got a design flaw there, Les.
What? I need a little more work on my mechanical stuff, as I said, as I mentioned earlier. But
all right. No, that's worth following up on. If you get any encouragement at all, let us know.
Okay.
I love the ideas of magnets for utility-wise, but as I post a lot, like the whole buckyball fiasco, where it's dangerous. Magnets are dangerous around kids if they swallow them.
Yeah.
That kind, but
Oh, yeah.
this just got me thinking. Actually, the way that if we took a fingertip and modeled it so the fingertip, the very tip of it was hollow, as it's printing, if you were to pause the printer and raise it, you could drop a magnet on the inside of the fingertip and then finish printing it, and you would actually have a magnet inside. You could glue it in there too. It'd be inside the fingertip.
Yeah.
So
I've printed things that way. That works just fine.
by dropping
somebody published a design for a bottle opener.
Yeah.
It uses a penny as the metal catch on it.
Right.
You can drop the penny in mid-print.
Mm-hmm. Yeah, I did a cat toy like that, and I paused it and dropped a bell in there. So you could almost do a finger, an index finger, if someone was a carpenter and they wanted to be able to hold nails. Well, I guess they're adults. They could just glue one on there, but being able to have a magnetic fingertip is just a fun idea, I think.
It is.
Yeah.
And you're right, though. You got to protect it from kids swallowing it. It could be very dangerous.
That'd be a good way to do it. And what kid wouldn't want a magnetic finger? That'd be great.
Pick up any small metallic objects you drop.
His Hot Wheel car.
Right.
Yeah. I might play with that.
Bolts and screws.
Move his pencil around on his desk at school with the eraser.
Yeah, actually, making things like handlebar gripping terminal devices could utilize a magnet, couldn't they?
Yeah, if we had a strong magnet, that'd be a great idea. Yeah, and it doesn't need to be fingers, but it can be, a curved hook, and on the inside of it have really strong magnets. And then the bike handlebar, you take the rubber off. They don't need the rubber on there, and you can just magnet right onto the handlebar. That's a great idea.
And then
it also could wrap around, and the magnet on a fingertip could attach itself to a magnet on the palm, so that once it's gripped, it would stay gripped.
I don't know if those would be strong enough. I think it'd have to be something dedicated.
Yeah, right. But it could be like take the place of Velcro.
Good idea. So, has there been much discussion in these talks, because I'm so new here, about the notion of having a little processor with sensors and actuators that provides additional, sort of spidey sense kind of stuff for, especially for kids?
I've been excited about the. There's an Arduino from Adafruit that is about the size of a thumb drive that would be a lot of fun to. Trinket is the name of the project. It's their Trinket Pro is a full Arduino capable embedded processor that you can easily run with fairly low power.
Yeah.
Yes, I'm very familiar with those because I use the chip behind them in a DIP format, using a programmer made by SparkFun. It's the ATtiny85, and recently I got into the ATtiny84, which is the same chip but with more I/O. And
yeah, I think there's some real opportunities there, Les, and trouble if anybody has some ideas to explore and you'd like to, I'd encourage you to go for it. But we've got people in our community that are working on very sophisticated myoelectric prosthetic devices, computer brain-controlled arms and whatever. But you don't have to go that far. There's a lot of electronic things that'd be useful on a wrist-actuated hand. you know, electrical and electronic, little power screwdrivers and things like that. That you know, you could like move your wrist and hit a micro switch, you know, and turn on your electric screwdriver and move your wrist the other way and make it go the other direction, or something like that. Things that hook up to your Picatinny rail, but there could be electronic sensors and all kinds of things for a hand that was not a myoelectric hand, but it would have some functions that would be useful as a terminal device accessory. So anything that occurs to you, you know, it's fair game in my opinion.
The ideas I had, one of them was use an infrared phototransistor, just bias it up and send it into the analog sensor input of an AT-Tiny 85, and then, or 84 rather, be better. And then put a lens in front of it with the focal point on the phototransistor and the distance and, you know, shape of the lens designed to give it a beam, a straight beam. You know, much like those, you know, a flashlight that points, that's focused to a beam, you can also do it the other way. And you can buy these thermometers that for industrial use, where you can sense the temperature of a industrial motor from a distance with safety, using that technique. So we can have on the back of a hand, actually, you know, quite frankly, I'd like to have one of these, the fact that I have a good hand, I mean, on a regular hand, but just something that sits on the back of the hand and has one of those arrangements, and then uses a, as you had mentioned before, a power resistor, actually just a regular resistor with a 1/10 watt maximum output power, I think would be about right. And then when the thing on your wrist gets warm, you know you're looking at something that's hot. I mean, I could see that for firefighters, for example. You know, or anyone who has to deal with high temperature things, you know, like these, and this gets into the superhero aspect, where we're talking about not just hands that look like superhero stuff, but hands that do superhero things.
Superhuman traits.
Yeah, and it's really cool if you can use something off the shelf and use a Picatinny rail or something to attach it to your system. That'd be really cool. You can get one of those infrared thermometers that you can, you know, use. I use one in the kitchen when I'm cooking all the time to tell how hot my stove is and so forth. They're like $35 at Lowe's or Home Depot.
Oh, it's amazing how quickly things change.
Yeah.
It wasn't too long ago. It was an industrial only kind of thing, but
yeah.
Yeah, I don't get out much.
I'm looking at the sidebar chat and the comment from Nancy Court. She says, my daughter's long-term idea is to make a fencing arm that can hold the fencing weapon grip. So all interesting stuff, the ball joint and the articulated arms. To the lady in the Hangout, would love to know more about how you set up the EMG sensors. Is that hooked up to Arduino? Which sensor make you use?
Hold on. Okay, so right now we're using I think we got it from SparkFun or something like that, and we're running it through a few different ideas just to figure out the voltage outputs, but we're running it through an Arduino Uno just to get a sensor to go. So I think we're using a potentiometer to go to the servo motor to wind up the strings. That's the game plan right now. We're still kind of experimenting with it, though.
Yeah. There's been some, you know, interest in discussions in doing those kinds of things. So I think those are great forum topics. You know, yeah. So if Nancy could put a question on the forum, and somebody will answer it and get a thread of conversation going, that'd be great.
Nick Parker did some interesting experimentation with the EMG sensors from SparkFun, where he tried to reverse engineer them. They're basically just an amplifier and a resistor to try to get rid of the extra noise that's not intended to be there. And so he was doing circuit designs in a Hangout probably a year and a half ago, maybe more recent than that, maybe last summer. But yeah, the EMG sensors aren't terribly complicated objects. They just need to be able to feel the magnetic or the electrical field in your arm and respond to them.
Yeah.
Yeah, so there's a lot of people that are playing around with those things, and so if you ask a question on our new forum, you'll probably get some answers.
Yes. Would you guys like to have a little extra announcement about the forums for those that aren't aware of it yet?
Yeah, go for it, Lydia.
Well, it's just now gone up. Yesterday and today were the first couple days. We decided on PHP BB, and we are at forums.enablingthefuture.org. So come on over and register and start poking around and looking around.
And ask questions, and I bet you get some good conversations going.
Yep.
Right.
So are we using this instead of like the Google Plus thing now, or sorry, I'm kind of a little behind.
It's in addition to the Google Plus group, actually, but we're starting out mostly using it for R&D conversations, so this is kind of an apropos group for me to mention it in.
And the question about, like, how would you make a sensor for a terminal device to hold a fencing weapon grip or something, you know, that's a perfect kind of a question to go in that kind of a forum, I think.
Yeah, the PHP has better threaded conversations. It allows us to post images in comments. It allows us, you know, there's a lot of extra things like that it allows us to do that we can't do with us.
Okay, so you can put images and so forth in your responses, which you can't do on the Google Plus.
Right.
Right. You can't put that in. You can't put images in comments on Google Plus. No.
Right.
But just so you know, it's mostly we're talking JPEGs. You can't put actual STL files because that would take up too much room for us to back up and store.
Okay. But you can put hot links to
Exactly.
a Google Drive.
Yeah, you can put links till the cows come home. That's totally fine.
Okay. Very good.
It's just actual STLs are a bit big to have for us to be dealing with on the actual forum.
Okay.
So yeah, it's kind of exciting. I haven't signed on to it yet. I'm going to try to do that in the next couple of days.
Yeah, I think I'll take a look at it after this meeting, after this hangout, because I remember I got involved with a music forum in 2007, and it was very meaningful to me. I like to write, but I don't like to write books and things, you know, or blogs or whatnot, but more like short little writings, and the forum is just perfect for that.
Right.
And if you get a wild idea, you can just post it and see if someone responds to it, or see what someone else is talking about, and you know, it provides a great focal point for causing those kinds of things to have some lifespan to them.
Yeah, and the forum is completely open to the public as well. You know, Google Plus, our community, I know it feels public because we have 3,800 members, but you know, that'll still stay closed. You know, but keep in mind when you're posting, it's, you know, it's good. It's open to the world, so you never know what kind of ideas are going to come in. but also keep in mind, it's public, so don't put information on there, things you don't want shared outside of the community.
Yeah.
Oh, that's right. So we want to be careful about personal information for
Oh,
the
yeah.
recipients.
Yeah.
Is there gonna be somebody filtering it so everything like doesn't get buried? I guess so we don't have like not like we're gonna have thousands of posts, but so it's like everything doesn't get buried or be like multiple posts over and over again.
Well, that's what categories and subforms are trying to be for. I don't know if that's going to be enough, but this is sort of a work in progress, as everything in e-NABLE is. So it'd be great. The more people that are part of it, the more potential we have for feedback from people about what's working and what's not, and all that kind of thing.
My dad says we'll burn that bridge when we come to it.
Exactly.
I knew a guy used to say, "We'll jump off that bridge when we get to it."
Anybody else got any more show and tell?
I have unrelated show and tell. I think I showed it after the Google Hangout for the Hand-O-Matic. Oh no! The gears fell out. Let me get them. One gear goes here and the other gear goes here. Well, the story goes that I printed this very simple gear toy. This is the latest one, the most evolved one. It's got a planetary gear set, or also called epicyclic gear set.
Right.
And then it's got the annular ring is merged together with a bevel gear set. This is a little loose, but it works.
That's pretty cool.
Yeah, I'm thinking of going vertical with it, and making something that carves Play-Doh or what have you into little chess pieces or something like that. But anyway, I put it on Thingiverse, and it seems to be fairly popular. People like these gear sets because they teach their kids.
Right.
And the touching story that goes along with this is I made a gear set with only 2 gears. One was about as big as this whole thing, and the other one was a third the size, and on a base. That was gear toy number 1. This is gear toy number 4. And my mom says, "Oh, can I have that?" Sure. Never thought about it since. And just recently found out that my niece, who is just 1.5 years old, something like that, it's one of her favorite toys.
Wow.
And she turns out to be a little engineer, so.
Great.
So, and she even took the big gear night with her in her crib, so I was just so touched by that,
There you go.
And I could make something that would make a 1-year-old smile, and so of course I redoubled my efforts and made more stuff to give to her. So there's a little show and tell that's slightly unrelated, unless we want to 3D print gears for our hands.
Well, you never know where you can use that technology. It'll pop up in a strange place when you're trying to put a ratcheting thing on a tensioner or who knows what, You'll use it. That's cool.
Oh, thanks. Yeah, it's good to have that knowledge and the ability to print it.
Well, I'm kind of winding down. Who else has got something new to share?
To the conversation, Steve?
Yeah, Steve, you got anything you'd like to contribute?
All right, hold on. Obviously, I wouldn't record these. Okay, I think I've run out of topics, and I think I need to go to bed because I'm starting to hurt.
Yep.
I'm in that fix too. This was fun. Thank you very much, Trouble, and for all of you for your contributions.
My favorite thing about these is those half-baked ideas. I can throw them out and somebody grabs and runs with them and produces a really nice product as if I wasn't just some idiot throwing out random crazy ideas.
Yeah, for a very long time, I have kind of worked in a vacuum, coming up with ideas and writing them in little books, and the books get lost and the ideas go nowhere. It just, the hive mind is so much more powerful.
Yeah.
So it's good to be a part of something like this now.
It's a lot of fun too.
Yeah, I had a good time tonight as well as usual. So I'll see you all on the forum.
All right.
Thanks, guys.
Yeah.
Bye-bye.
Bye-bye.
All right.